Okay, so today we're going to finish up genetics. On the last video, I went over pretty much a lot of stuff with genetics, but it was the easier stuff. Today, I just want to go over two different things of genetics. One is going to be blood typing, and the other one is going to be sex-linked inheritance, okay? So we're going to start off with sex-linked, and then we'll go to blood typing. Now, last time we talked about with the genetics and the different types of inheritance, we talked about the chromosomes, and we even talked about the chromosomes in mitosis and meiosis. I'm going to come back to those. If you remember, we have 46 total chromosomes. We have 46 total. However, they're in pairs. So it goes from chromosome 1 all the way to chromosome 23. And we have, in chromosome 1, we have 2 of those. In chromosome 2, we have 2 of those. And so on and so forth, all the way up to number 23. Now, number 23 is a special chromosome, right? Number 23 is our sex chromosomes. Now, if you are, and I'm going to write them here, if you are a female, your sex chromosomes will look like this. You will have 2 X's, and you will have no Y's, right? This is a female, okay? If you are a male, your 23rd chromosome will look like this. You will have an X, and you will also have 1 Y. Now the Y is much, much, much smaller than the X, okay? That tells us the Y is not going to carry as many traits. So we got our male here. Another way to write these in non-karyotype form, males are XY, females are XX, okay? Now, this is the chromosome we're going to deal with today when it comes to sex-linked inheritance. For sex-linked inheritance, we are going to pretend, for our intents and purposes, that only the X is going to carry these traits we're going to go over today. So, again, sex-linked inheritance, this is going to be traits that are carried on our sex chromosomes. In other words, only number 23. Number 1 through 22, those other chromosomes we have, 1 through 22, they're called your autosomes. Those ones are going to be the other types of inheritance. That's going to be complete dominance, incomplete dominance, and codominance. Okay, so let's get to it. Sex-linked. These are going to be things like color blindness, male pattern baldness, all right, and that's all. I'm just going to go over those two for now. So color blindness, male pattern baldness, again, these are going to be carried on chromosome 23, specifically the X chromosome. So let's talk about this. Let's do females here, and we'll do males over here. Now, a female, like I said, this is sex-linked inheritance. It's on chromosome 23. What we're going to do for each one of these, start off writing their sex chromosomes. Females are XX, males are XY. Okay? These traits are only going to be carried on the X. So the Y is literally going to have nothing. And how we write these traits, how we write the alleles on these sex chromosomes is we are going to superscript them up, and I'll show you that in a second here. So let's deal with color blindness here. I'm just going to use B for our alleles. The reason I don't like to use C is because capital C and lowercase c, if you don't write them, in their right size, they look identical. So I'm going to use B because capital B looks completely different than lowercase b. So if a female is big B, her vision is good. Everything is cool there. Okay? A female could also be heterozygous, so X big B, X little b. And this is inherited by complete dominance as well. Sex-linked tells us it's on the sex chromosomes. Complete dominance tells us that if it's big B, little b, she's going to have good eyesight, okay? However, if she is homozygous recessive, she will be colorblind. So if we look here in females, they have two genotypes here that save them, in other words, give them good vision. We have one genotype, so 1 out of 3, that gives them the colorblind vision. Let's go over to males. Remember, guys, the male has that Y, and that Y cannot carry these certain traits. So the male could be X big BY. That means they have good vision. Nothing on that Y again. The male could also be X little by, and that is when they are colorblind. Okay? So there's those two right there, and that's it. You're not going to have 3 genotypes like you have in the females because these are your only 2 possibilities. Also, we find that there's only 1 genotype that saves the male, X big BY, where there's 2 that save the female. This is why more males are colorblind than females, okay? And the same thing goes with male pattern baldness. You know, when the guys just start losing the hair on top of the head. Females, X big B, they got all their hair. X big B, X little b, they got all their hair. They need 2 recessive alleles to be bald. Same thing with the males. X big BY, they got all their hair. X little by, they go bald, okay? This is why more males are bald, and females, we really don't see it that often, okay? So, that's how you do sex-linked inheritance. Let me do a Punnett square for you real quick. So, here's the problem. Let's say that we always got to have a male on one side and a female on the other side, guys. That's the way it works, okay? We're making kids here. So we need a male and a female in our boxes, okay? I'm going to put the male up top. So we know the male will be X, Y. We know the female will be X, X, okay? Actually, let me do a different color for there just to differentiate. So before I even do anything, put my alleles in, let me show you guys something. I'm going to carry the X's and the Y's down. So I carry the red X over to each one. Let me carry the blue Y's from the male and the blue X from the male. Okay. This Punnett square right here shows us that we actually have, every single time we produce a baby, there's a 50% chance of having a female and a 50% chance of having a male. So that's how it's always 50%, no matter what. You have 10 kids and they're all female, the next chance of getting a female is still 50%. It doesn't change, okay? All right, so let's cross a female that is not colorblind, but is a carrier for it. So if you see carrier anywhere, what this means, if she's a carrier, she has the trait for it. She has the trait, but she doesn't have the condition. So I said that she is not colorblind, but she's a carrier for it. So she's going to be X big B, because she's not colorblind, but she is a carrier, so the second one's going to be a little b. Again, she's not colorblind though. The male, let's say the male is not colorblind. He's going to be big B. Pull everything down. Big B, big B. That big B comes down, little b comes over. This big B comes over, and this little b comes over as well. Okay? So, if we look here, guys, what is the percent chance a child will be colorblind? Well, that one's not colorblind. That one's not colorblind. That one's not colorblind, but ding, 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 that one is. So 1 out of 4, 25% chance of being colorblind. Now, let me show you how problems can screw with you a little bit. If they were to say, what percent chance does a male have for being colorblind? This is where things change. So here, these are both females. The problem wasn't asking for that. So I'm just going to cross them out because I don't need them. What percent chance does a male have of being colorblind? Well, these are the only two males over here, so it's actually 1 out of 2. So the male has a 50% chance of being colorblind. That's where your difference is, okay? So if they just talk about a child, you talk about all 4 of the ones in your Punnett square. If they are going to talk about a certain gender, male or female, that's when you got to only target in on 2 of them, whatever they are, male or female. Okay? All right. That's sex linked. Let's do some blood typing now. So blood typing is very, very, very tricky because it combines so many different forms of inheritance that we went over last time. Now, for blood typing, we don't have to worry about the positives and the negatives. And students every year are like, hey, okay, I'm A negative, I'm O positive, okay, whatever. We don't have to learn about the positives and the negatives, in other words, the RH factors right now. I'm only going to worry about the letters, the A, the B, the AB, and the O. So, your phenotypes for blood. You can be AB, you can be A, you can be B, or you can be O. These are your 4 blood types, okay? You ever go to the doctors, they will say you have one of these 4 and that it is either positive or negative, okay? But like I said, that's the phenotypes. That does not tell us our genotypes. Remember, for a genotype, we always need 2 alleles. So, let's look at our genotypes here based on our phenotypes. Here's what you have to remember for blood typing. A and B are codominant to one another. What this tells us is there is not a recessive allele between A and B. Second part here. A and B are dominant to O. So they are going to mask the O. Okay? So, A and B are codominant. A and B are dominant to O. And we need 2 alleles for each one. So, genotypes. AB blood. Our genotype is just AB. Nothing is crazy there. Second one, A. Let me draw a little thing here. All right, A. We can have 2 different genotypes for A. They could be AA, or they could also be that dominant A with the recessive O. And that O is masked by the A because it's recessive, okay? B blood. You could either have 2 B alleles, or you could be BO. And then our last one, O, that's all recessive, so it's just OO. Cool? All right. So that is the genotypes and the phenotypes for blood type, okay? Now, let's say hypothetically, let me give you 2 examples here for blood typing. Let's say that we had a male that has heterozygous A blood. Okay? And he has a child with a female. We'll do B blood. Okay, so male, heterozygous, A blood. Female, B blood. We're not sure about the other one. The child has O blood. Okay, here's what we're going to try to find out. We want to find out, what is that female's genotype? We know her phenotype. Phenotype is B. Okay, she could be BB or she could be BO, but we don't know. We know the dad is heterozygous A, so we know dad is AO. Okay, we know the mom, her first allele has to be B. She can't be AB because it would say she has AB blood. So we know the first allele is B. So this one would be AB, this one would be BO. So we have AB blood here, we have B blood here. Child has O blood. Well, this one, carry that A down, that's already an A. So this one can't be that child, this one can't be that child, this one can't be that child. This one has to be that O child. So we know O blood would have to be OO. We brought that O down. This other letter over here would have to be an O. So the mom, her genotype would have to be BO. She could not be BB because then they wouldn't be able to have a child that's O. Cool? All right. So another thing I always like to do with blood typing, because it's fun and exciting, you always have some crazy problems with blood typing. You might have a spouse cheating on the other part of their marriage. That's not fun. All right. We could have some crazy scenarios come up, but I always like this one. I always like this one. All right. So mom has O blood. Okay. Mom has O blood. Dad is AB. Okay. The child, their baby, also has AB blood. What happened there? Let's determine some things here. Okay. So I'm going to color code this the best I can. We're going to make the dad blue, and we're going to make the mom red. So the mom is OO because she has O blood. Dad is AB. All right. So right here, we would have A coming across to both of these, B coming across to both of these. Bring our O's down. The child can only have A blood or B blood. They cannot have AB. So what happened? Well, did the mom cheat on the dad? And that's not the dad's baby? No, she did not. In reality, what happened here, guys, is that mom, it doesn't matter who she has a baby with. She's got O blood. Her babies can only be O, A, or B. She can never have a baby with AB because she doesn't have an A or a B allele to give to that baby. So in this scenario, if the hospital gives her a baby and they say it's AB and she's O blood, that is not her baby. The hospital made a mistake and definitely gave her the wrong baby because there's no possibility she can get a baby with AB. Okay? All right. So that's blood typing, guys. Pretty much gave you the skinny on it, and sex-linked inheritance. So that is it with genetics, guys. Okay? These ones are the hard ones. Okay? So maybe, take some time, go through them. But that's pretty much it, guys. All right. Have a good rest of your day.